Moving on, away from a concrete representation, I want to show my students how to use a different representative method. In this case, we'll use circle drawings. So as they grow more familiar with this concept, they can begin to use their own drawings or their own representations of numeric values. In this case, we'll do circle drawings. Here I've just got a circle, and then here I've got a filled in dot that kids can use. They can draw these into their own 10 frame to help them um, get more familiar and more acquainted, competent with addition and subtraction. So we'll work through these problems in the same way. Here we have 4 plus 5. The first step is to represent each digit using our two manipulatives or our two drawings here. So the first one we'll do 4 of this circle. 1, 2, 3, and 4. And now we need to add 5 more. So we'll add 5 more of these guys. 1, 2, 3, 4, and 5. And the final step, of course, is to count the total. 1, 2, 3, 4, 5, 6, 7, 8, 9, for a total of 9. 4 white ones plus 5 black ones is going to equal 9 total for our sum. And subtracting is the same way. So we'll get rid of these guys to begin our subtraction problem. Here we have 7, so we'll represent 7. There's 1, 2, 3, 4, 5, 6, and 7. And then we'll take away 6. 7 subtract 6. 1, 2, 3, 4, 5, and 6, leaving us with 1. So we know that 7 subtract 6 is going to equal 1. Last thing I want to show my students, using this visual model of a 10 frame, is what I like to call turnaround facts, or a decomposition of what two numbers make. So to begin, 7 and 2 make, well, I don't know. Let's find out. So let's do 7 of these guys. 1, 2, 3, 4, 5, 6, and 7. And now we'll add 2. 1, 2. So let's count. 1, 2, 3, 4, 5, 6, 7, plus 2, 8, 9. So we know that 7 and 2 make 9. We'll underline that one. 7 and 2 make 9. So now, a turnaround fact is essentially a fact family. So here we have 7 and 2. We know that those added together make 9. But the cool thing is that you can actually turn these around, switch the places of these two factors to where 7 and 2 become 2 and 7. This looks like a completely different problem, perhaps to a kindergarten or first grade level student, but it actually equals the same exact thing. 2 plus 7 equals 9, and that can be actually represented on this. Let's say we have 1, 2. We haven't added, we'll pretend we haven't added these white ones yet. We'll represent the 2 with these, and then we'll add our 7. 1, 2, 3, 4, 5, 6, 7. Still comes out to make 9. And subtraction works the same way. 9, here we have a total of 9 minus 7, which is one of our first digits, right? Let's take away 7. 1, 2, 3, 4, 5, 6, and 7. That's going to equal our last digit here, 2. And then the same goes for 9 minus 2 is going to equal 7. So 7 and 2 make 9. We have 7, 2, and 9, and that problem can decompose 4 different ways. 7 plus 2, 2 plus 7, and then 9 minus 7, and 9 minus 2. And as you'll see in each problem, all of the digits that we have used were from this original problem here. So in conclusion, that is how to represent addition and subtraction using